In this video, we're going to discuss the product rule for differentiation. So the product rule. We want to find the derivative of the product of two functions. So f of x times g of x. We want the derivative. The formula is the first function times the derivative of the second function plus the reverse. The second function times the derivative of the first function. So the derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. And this formula is very friendly. If you switch these two and do the second times the derivative of the first plus the first times the derivative of the second, that's the same. And then you could switch the order of the multiplication within the terms. F prime of x times g of x plus g prime of x times f of x. So it's a very friendly formula. You can switch things around quite a bit and get the same answer. But I like to remember it as the first times the derivative of the second plus the second times the derivative of the first. Although I don't always use it in that format, sometimes I prefer the second times the derivative of the first plus the first times the derivative of the second. It depends on the nature of the functions involved. And in fact, I think in many cases I actually prefer this form, f prime of x times g of x, the derivative of the first times the second, plus, and then actually on this one, I think I might even prefer f of x times g prime of x. But at any rate, the idea is one function times the derivative of the other in either order, plus the reverse in either order. So the order you pick depending on the functions and their form and what looks like the nicest way to write them. Let's look at a couple of examples. Let's suppose that we have a polynomial of degree 2 times another polynomial of degree 2. And we want the derivative of the product. It is possible to simply multiply these two together and get one polynomial of degree 4 and then take the derivative term by term. But let's practice using our product rule. So according to our product rule, this function is a product of two functions, the first and the second. So the derivative is the first times the derivative of the second. So what's the derivative of 3x squared minus 2x minus 5? We go term by term using the power rule. We get 6x minus 2. The derivative of the constant is 0. And then, so that's the first half of the product rule. That was f times g prime plus g times f prime. So 3x squared minus 2x minus 5 times the derivative of the first, which would be 2x minus 3. Okay, so there's the derivative. If you wanted to do something with it, you might want to multiply this together and multiply that together and then add, and you would end up with a cubic polynomial. You would get an x cubed there and more x cubes there. It looks like you would end up with a cubic polynomial. Let's look at another example. Suppose we want the derivative of x cubed times the cube root of x. So we could use the product rule. We have the first times the derivative second plus the second times the derivative of the first. The derivative of x cubed is 3x squared. And now what is the derivative of x cubed? So let's do an aside. The derivative of x cubed, the derivative of the cube root of x, that's the same as x to the 1/3 power. Cube root of x is the same as x to the 1/3 power. The derivative of that using the power rule is 1/3 times x to the minus 2/3. We have to subtract 1 from the power, so 1/3 minus 1 is negative 2/3. So here we have x cubed times 1/3 x to the negative 2/3 plus the cube root of x times 3x squared. And that's one way to write the answer that's not very appealing. For this particular problem, actually, I wouldn't recommend using the product rule. I would recommend taking advantage of the fact that the cube root of x is a power function, and then multiplying the functions together by adding the exponents. Power function times power function, you could add the powers. 3 plus a third. 3 plus a third. 3 is 9/3, and therefore 3 plus a third is 10/3. So this is, we're trying to differentiate the function x to the 10/3. So we can just use the power rule. 10/3 x to the, subtract 1, subtract 3/3, so x to the 7/3. 10/3 x to the 7/3. There's a nice form for the derivative. So in these first two examples, the product rule technically wasn't even necessary because we could have actually performed the multiplication. We could have performed it here, I didn't. We could have performed it here, and in fact I did, and it I think is a little simpler. So in calculus, whenever we're going to do a calculus operation, we should always check to see if there's algebra operations that we can do first that will make things simpler. So let's look at some situations now where you really need the product rule because there's no way to combine the functions. The simplest example is looking at the derivative of x times e to the x. This is a product of two functions, and there is no algebraic way to simplify x times e to the x. So if we want the derivative of this, we must use the product rule. So it's the first, which is x, times the derivative of the second. So in order to use the product rule here, we need to know this formula. The derivative of e to the x is e to the x. So the first times the derivative of the second plus the second times the derivative of the first. And now we can make this look nice by factoring the e to the x out. And I'd like to write polynomial on the left, then exponential on the right. So if you factor out e to the x, you're left with x plus 1. So the derivative of x times e to the x boils down to x plus 1 times e to the x. Let's take the derivative again. So what is the second derivative of x e to the x? So we take the derivative of this. It's x plus 1, the first, times the derivative of the second, plus the second times the derivative of the first. The derivative of x plus 1 is 1 again. And then we can factor out the e to the x. And what do we have left? X plus 1 plus 1 is x plus 2. So the second derivative of x e to the x is x plus 2 times e to the x. And something nice is happening. Let's compute the third derivative of x e to the x. So we had the times e to the x. In the end, we get the first, x plus 2, times the derivative of the second, e to the x, plus the second, which is e to the x, times the derivative of the first, which is 1 again. Factor out the e to the x, and you're going to get x plus 2 plus 1. X plus 2 plus 1 is x plus 3. So x plus 3 times e to the x. And this pattern continues. In general, the nth derivative of x times e to the x is going to be x plus n times e to the x. So there's a nice little pattern, and we got some practice with the product rule. Another example, let's try an example involving the logarithm. So what is the derivative of x squared times ln x? The derivative of x squared times ln x. Again, we have a situation where we cannot algebraically simplify. We have a product of two functions, x squared and log x, and there's no way to simplify that expression by actually performing the multiplication operation. So we use the product rule to find the derivative, and we get the first times the derivative of the second, plus the second times the derivative of the first. And here is an example where I like to switch the order. It's going to be, I'm going to write the derivative of the first times the second. So 2x log x. It's nice to write the polynomial before the logarithm. And now in this particular example, the answer can be simplified nicely because x squared times 1 over x is just x. So we have x plus 2x log x. So the derivative of x squared times log x by the product rule is x plus 2x log x.